Hello guys, welcome back to my YouTube channel. This is my 8th video and second in line for my series of videos which I have started from my previous one, which is basically aimed at providing free of cost preparation and materials and guidance to all those who are aspiring for ISI 7 other entrance examinations. As I said, I am following a series of chapters which you can very well have a glance by viewing my blogging channel, that is sunnylovesmaths.blogspot.com, which I will be posting it up in the description box of this video, so do check it out on the down. Before this video, in my previous one, I had basically discussed what is a polynomial function. Then I had come to down to some properties of polynomial functions. Then I did a division of polynomials, and then I covered up remainder and factor theorem, two of the very basic but very critical and important theorems. And we did some problems which I had told you to practice it from Tomato, that is Test of Mathematics at 10+2 level, which is the official book for ISI prepared by the professors at ISI. Today is the lecture 2 of that same polynomials chapter, which I will be starting by doing some questions. Okay, so today's first question is, before I move on to some topics, we will be practicing some good questions. Two questions basically, then I will be moving on to important theorems, which includes the rational root theorem and the integer theorem, and then I will be going for symmetry expressions and Vieta's relations. So that is our agenda for today. So I'll be taking my black. Where are you, my black? Yeah. So my question says, Px is a polynomial such that, what is it given? X into P of x minus 1. X into P of x minus 1 is basically given to be x minus 4 into P of x. This is an equation given which has my polynomial P of x for all x belonging to reals. We need to find all such P of x. Okay, so what are we given? P of x is a polynomial where x is any belonging to reals. We are given one equation, x into P of x minus 1 is equals to x minus 4 into P of x. We basically need to find all such P of x. So how do we do this? Solution time. Nice question, I would say. So, what are we given? X into P of x minus 1 is equals to x minus 4 into P of x at x equals to 0. Suppose, what am I getting? 0 into P of 0 minus 1, that is P of minus 1. This is basically your minus 4 into P of 0. This term becomes my 0. So ultimately, what am I getting? My P of 0 tends to be 0. This is my first equation. Now, at x equals to 1, what do we have? 1 into P of 0. That is basically your 1 minus 4. That is a minus 3 into P of 1. P of 0 is 0. So here what am I getting? My P of 1 is again 0. Next comes Let me put x equals to 2 and see. I'm just trying to find out a pattern. Two into p of 1 is basically minus 2 into p of 2. What am I getting here? P of 2 is again equal to 0. This is my third equation. Now comes at x is equals to 3. Similarly, we will be just putting my 3 in place of x in this equation. So what do I have? 3 into p of 2 is basically your minus 3 into, is it minus 3? No, sorry, just a second. Yeah, x minus 4, that gives me minus 1 into p of 3. So ultimately p of 3 is again equal to 0. Cool. So what do we get here? At x equals to 0, x equals to 1, x equals to 2, x equals to 3. For every x, p of that x is equal to 0. So we can have basically say that we have find out the 4 roots of p. So therefore I can write my, I don't know the degree of p of x, that is a thing to remember. Otherwise we could have easily told that p of x is 4 roots, but we are not sure that it's a quadratic equation or not a quadratic equation. It may be greater. So therefore p of x, basically it's an assumption I can take my p of x to be x into x minus 1, as I told you in the factor theorem, since they all are becoming 0. So my x minus 1 is a factor since 1 is a 0 of the polynomial. Similarly goes for 2, 3 and 0. So x into x minus 1 into x minus 2 into x minus 3 into, let me take a k of x. Since I don't know my degree, so I am just letting it to be, I have got my 4 roots and into that multiplied by k of x, where my k of x is basically a polynomial. Good. Next, what do we have? We try to put this p of x in the equation which was given at the earlier, that is my original equation. What do we have? Now since x into p of x minus 1 is equals to basically your x minus 4 into p of x. So x into p of x minus 1, so that gives me basically your x minus 1 into x minus 2 into x minus 3 into x minus 4 into q of x minus 1 is equals to x minus 4 into my p of x. What do I have? My p of x, x into x minus 1 into x minus 2 into x minus 3 into k of x. Okay, so what can I do? I can see that some things are getting cancelled on both sides. So x and x gets cancelled. X minus 1 and x minus 1. Similarly, x minus 2, x minus 2, x minus 3, x minus 3, and x minus 4, x minus 4. This is my k, okay? It's not q. So what do we get here? K of x minus 1 is equals to k of x. That shows my k of x is a periodic function. That means it is getting repeated time to time. by putting a certain value. For an example, like my sine x is a periodic function. How? Since sine of 0 is 0 and sine of pi is also 0. So that means basically sine of x has a period of pi. Yeah. So my k of x is a periodic function. I can denote a periodic function to be sort of C. Yeah. Random. Hence, I get my answer here directly. My p of x is basically some constant c into x minus 1 into x minus 2 into x minus 3. So this is my p of x, and fortunately this is my answer true. I hope everybody is clear with this easy problem, a little trickery, a little knowledge of periodic functions, but yes. So once more, we were given an equation that is x into p of x minus 1 is equals to x minus 1 into p of x. We took randomly 4 values of x to check out some things which could be of great help to us. So initially we took at x equals to 0. My p of 0 was coming out to be 0. At x equals to 1. My p of 1 was coming out to be 0. At x equals to 2, my p of 2 was coming out to be 0. At x equals to 3, my p of 3 was coming out to be 0. So I easily took my p of x to be, since we do not know the degree, but I know my 4 roots at which my p of x is becoming 0. I basically took x into x minus 1 into x minus 2 into x minus 3 into k of x, where k of x is a polynomial, to form the polynomial p of x. Put it in my relation, got a relation between k of x and k of x minus 1. Since both of them are equal, so basically I can tell my k of x to be a periodic function since it is getting repeated after a certain interval. So I could take my k of x to be a constant, and hence k of x, hence p of x. We'll take a look at it. Okay, I hope everyone's clear with this. Moving on to the next problem. Back. Next problem is, we are given p of x is a monic polynomial. That means the coefficient of the highest degree term is 1. It is given that my p of 1 is 1, p of 2 is 2, p of 3 is 3, and we need to find p of 4 equals to how much? Mind you, this is given to be a monic cubic polynomial. Easy problem. This is relatively much more easier problem than the previous one, directly based on pattern remainder theorem, sub part of my remainder theorem. Pattern remainder theorem. How do we do this? Easy one. My p of x is given to a monic polynomial, so basically I can take this to be some sort of x cube plus ax square plus bx plus c, a cubic polynomial, monic cubic, and we are given my p of 1 is 1, p of 2 is 2, p of 3 is 3. If you notice the pattern, x, 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 and x again. So basically my pattern is p of x when putting on a certain value always gives me the remainder x. So how can we write my P of X? As I had told you in my remainder theorem, my pattern remainder one question we had done of US motor and 1984. Most probably yes. What I told, just make a polynomial out of the given values, and we are lucky here. How? We are given a P of X which is cubic, and we are given three different values too. So basically you can take, we have got those three different values. So my P of X is basically x minus 1, x minus 2, x minus 3 plus x. This is my pattern. Kind. Good, yeah. Fair and fine. We need to find out most probably P of 4. This is as simple as a cupcake right now. P of 4, just put 4 in place of x. So P of 4 is basically your plus 1, 3 into 2 into 1 plus 4. So that gives me 10. So ultimately my P of 4 equals 10. This is my answer. Easy one. Direct application of my pattern remainder theorem. There's two problems initially for today. Now I will be moving on to some important theorems. Two important theorems basically. One is the original one, and another one is the corollary of that. So basically, let me take my yellow or the orange here. Agenda. Rational root theorem. Integer root theorem. Then Vieta's relations. And symmetric expressions. This is if I get time then. Since Vieta's relation is basically a big topic and symmetric expressions is just an extension of Vieta's relations. Starting with agenda number 1, which is my rational root theorem. I had done this on one of my previous videos. I hope you must have seen it. If you don't, then just check the video. I will also be putting the link of that video in the description box for better visuals. So yeah, rational root theorem. What does this theorem say? Proof, I won't be doing it again. I am just studying the theorem. I will be showing you the proof there, making you understand it. Easy one. Yeah. I am given a P of X, which is your a n x to the power n plus a n minus 1 x to the power n minus 1. My general polynomial equation plus a n minus 2 x to the power n minus 2 plus dot 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 plus a1x plus a0 equals 0. This is a polynomial equation. What does this theorem say? This theorem states that if, sorry, P by Q is a root of this equation such that Q not equals 0, P and Q both belongs to my set of integers, and GCD of P comma Q is 1. That means co-primes. If this is the case, then what is my basically P by Q? It becomes my rational number. Then my P divides A0 and Q divides, not divides, I will be putting on the sign of divides. Q divides AN. So this is what my theorem states. If P by Q is a rational number, that is my Q is not equal to 0, P and Q both belongs to my set of integers and GCD of P comma Q is 1, then my P divides A0 and Q divides AN. Time for the proof. Rational root theorem. Yeah. How is the proof? We know my P of Q is the root of the equation. So I will be just putting my P by Q in place of X in the given polynomial equation. So a n x to the power n plus a n minus 1 x to the power n minus 1 plus a n minus 2 x to the power n minus 2 plus dot 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 a1x plus a0 is equal to 0. P by Q is a root, so it's a 0 of the polynomial. So basically I can put my P of X in place of X. So an into P by Q whole to the power n plus an minus 1 into P by Q whole to the power n minus 1 plus an minus 2 into P by Q whole to the power n minus 2 plus dot 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 a1 into P by Q plus a0 equals 0. That means I am simplifying it, breaking it down, or probably, yeah, simplifying it. To simpler terms. Just a second. Just a second, guys. Yeah. So again, simplifying it, I will be multiplying my Q to the power n to all the terms in the equation. So a n P to the power n plus a n minus 1 P to the power n minus 1 into Q plus a n minus 1 into P to the power n minus 2 Q square plus dot 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 plus a 1 P into Q to the power n minus 1 plus a 0 into Q to the power n. That means that gives me 0. Now what do? I will shift my an into p to the power n. I will be taking my an into p to the power n to my left side, probably to my, sorry, to my right side. So I am left with a n minus 1 p to the power n minus 1 into q plus a n minus 1 p to the power n minus 1 into q square plus dot 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 plus a1 into pq to the power n minus 1 plus a0 into q to the power n is equals to minus a n into p to the power n. Now what do? Will take a q from the RHS, from the LHS, and shift it to the RHS, which is in the denominator. That means I take my q common, and that gives me minus my LHS, basically one short of q for all the terms. That is my a n minus 1 into p to the power n minus 1 plus a n minus 2 into p to the power n minus 2 q plus dot 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 plus a1 into pq to the power n minus 2 plus a0 into q to the power n minus 1 is equals to minus a n into p to the power n by q. So now, what have I said? My p and q are coprimes. That means q doesn't divide p and p doesn't divide q. That means q doesn't divide any power of p. That means p to the power n is not divisible by q. So ultimately, what are we left with? A to the power n has to be divisible by q since I had given a constant that my a n minus 1, a n minus 2 dot 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 up till all the way till a1, a0, they all are integers, and any linear combination of integers is basically going to give me a sum, is going to give me an integer. The sum of the linear combination of integers is going to give me an integer. So for that I need my RHS also to be an integer, and that is only possible if my an is divided by, is divisible by q. Since p is not divisible by q, so p to the power n is also not divisible by q. That means only one condition is left, which is an must be divisible by q, which proves the first condition, that q divides an. Now coming to my second part, I need to show p divides a naught, that is a0. Similarly, but here the twist is, here I had taken my, in the previous proof I had taken my an into p to the power n to my left hand side, to my right hand side, and here what do? I will take my a0 into p to the power n to the right hand side, and again take one p common from the left hand side and divide it in the right hand side. Similar things, if p doesn't divide q, then p doesn't divide any power of q, and I need my both LHS and RHS to be an integer. My LHS is already an integer, so for my RHS to be an integer, a0 must be divisible by p. That proves my second part. Good to go. I hope I am clear with it. Easy one. Proof is really easy. Just put and manipulate. So that is all for this theorem. I will just be writing it. Done in one of the previous videos, done in the previous videos. Corollary is integer root theorem. Integer root theorem, again very similar part, is a very similar theorem. Integer root theorem. Second, guys. Yeah, for my integer root theorem, only one change. My q is 1, so basically my p remains to be an integer and thus p divides a naught. That is all again shown in my previous video. I will write it on. Q is equals to 1, then p is an element of integer, so then my p divides a naught. Now its importance for finding roots of complicated equations. For finding roots of complicated equations. How do we do? Factorize the constant term. Factorize the constant term. This is the steps to find out the roots of complicated equations by integer root theorem. Factorize the constant or by rational root theorem, anyone is possible. Factors come out. Put the factors in place of x. Check for which value p of x equals 0. That is my root. Yeah. Good. Here with this. Now comes Vieta's relation. So probably one of the most important things of this chapter, polynomials. We have Vieta's relations. Should I do it right? Red looks fine. Yeah. So this is very, very important. So just I will be giving a star mark. Many questions which come from polynomials in UGA paper of ISI or JE entrance or CMI entrances or my college's entrance, that is IMS entrance, that is simply based on Vieta's relations. Now what is my Vieta's relations? Basically it's a relation between the roots of the equation and the equation itself. Yeah. So I am taking an f of x, the most general form, not the original polynomial equation, but general form, which is basically the way Vieta's relations is introduced to students. I take my f of x to be ax square plus, or yeah, so ax to the power n plus b x to the power n minus 1 plus c x to the power n minus 2 plus dot 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 one constant constant. I won't be showing it to you for general. The general case I'll be showing it in my symmetry expressions part, which probably I will be doing it day after tomorrow. So I'm gonna take you case by case to give you the real feel of what is this relation. So for n is equals to 2, my f of x would be ax square plus bx plus c. This is my general equation for x is equal to 2. That is my normal quadratic equation. Let its roots be alpha, comma, beta. For an quadratic equation, for basically not only quadratic equation, for any basic equation, I'll be just writing this. The main crux, the main concept behind betas relations is very important. Crux of this betas relation for any polynomial to be formed, we need sum of the roots and my product of the roots. Now you all must be thinking why I have left this big a gap. This is not for using of space, but some of the roots we have some bifurcations. Really millions of bifurcations. Taking one at a time, taking two at a time, so on and so on. The logic is for quadratic, or probably I will be saying this afterwards. Coming back to what we need up here, my sum of the roots alpha plus beta is minus b by a. These are some minute things which you need to remember. And my alpha beta is c by a. Now, if again monic, then my alpha plus beta becomes minus b since a is 1 and my alpha beta becomes c. My f of x can be formed, means oneself can form the equation by only knowing the roots and the relations. How? My f of x is basically x square this is minus b by a, so alpha plus beta is minus b. Here we have b, so we can basically write this to be here minus of alpha plus beta x plus c, that is alpha beta. So this is how to form an equation if we know the rules. Next comes, I will be generalizing, I will be showing it up to 4 and then generalizing, since though from 4 only we need to know symmetric functions, but I won't be doing symmetric functions today. I will be completing this till my cubic ones, my quadratic ones. I will be showing the generalized thing, and then we will be doing 2 to 3 questions and I will be wrapping up. I think my mic is doing a little bit of disturbance. This is the best thing. For n is equals to 3. My f of x can be your ax cube plus bx square plus cx plus d. Let my roots be alpha, beta, gamma. So my alpha plus beta plus gamma will be as usual minus b by a. Here comes my summation taking 2 at a time. That is alpha beta plus beta gamma plus alpha gamma, that is equal to c by a. Now comes up the product, that is alpha beta gamma is equals to minus d by a. From here we can notice down 2 things. One is for my product I am involving my constant term. Other than that I am involving only the summations, taking 1 at a time, taking 2 at a time, and so on and so on. And my signs are opposite. That is, my first one should be minus, second one should be plus, third one should be minus, fourth again plus, goes on and on and on. So 1, 3, 5, 7, the odd numbered results or the equations would be negative in signs, whatever may be the sign of b and a. And my second, fourth, sixth, and so on, my even numbered terms or equations should be positive in sign. Now, if my f of x is monic, that is equals to 1, I can write my f of x to be x cube minus of alpha plus beta plus gamma of x square plus alpha beta plus beta gamma plus gamma delta of x plus, or probably this should be minus, sorry, my mistake, minus alpha beta gamma. Sorry guys, spin just malfunctioned. No worries, let's pull again. I'm showing you the fourth one. But instead of fourth, f of x is a x to the power 4 plus bx cube plus cx square plus dx plus e. Excuse me. Roots are alpha, beta, gamma, and delta. So alpha plus beta plus gamma plus delta is minus b by a. This I can write it to be summation alpha. This is what we'll be learning in symmetric expression. Summation basically means a series. That is alpha. Summation alpha means I will not only taking alpha but alpha plus beta plus gamma. Yeah. Summation alpha is minus b by a. Next comes alpha beta plus beta gamma. Probably this is where mistakes can happen. So I'll be writing it sequentially down, taking two at a time. Alpha beta plus alpha gamma plus alpha delta. For beta, beta alpha is also already done. So beta gamma plus beta delta. For gamma, gamma alpha and gamma beta are already done. So gamma delta. And for my delta, I don't have any terms left. So basically you can see I am taking I have my four terms and I am taking two at a time. So number of combinations would be basically your 4C2. So basically 4 into 3 by 2. So that gives me 6. So that gives me your C by A, or else to write in summation terms, summation alpha beta is equals to C by A. Next comes my summation of the products taking 3 at a time. So for my 4 I have to go for my maximum summation to 3 at a time. For my 3 I had to go to 2 at a time. For 2 I had to go to 1 at a time. So basically for nth degree I had to go to the summations of n minus 1 at a time. Drink some water. Alpha beta gamma plus alpha beta delta. But this way it's gonna be very confusing. We know my 4C3 is going to be there since I have my 4 terms and from them I am taking 3 at a time. That gives me basically 4C1. So I'll be having 4 terms. This is going to be my d by a minus d by a, and then I am left with alpha, beta, gamma, and delta. So that is going to be minus b by a, c by a, minus d by a. That is going to be e by a. Now again, if fx is monic, my f of x is going to be x to the power 4 minus summation alpha x cube plus summation alpha beta x square minus summation alpha beta gamma x plus alpha beta gamma and delta. So this is going to be my f of x. F of x is monic. I showed you 3 cases. I will be generalizing them in my symmetricity part of the roots. These are my 3 cases, Bette's relations. So time to do 1 or 2 problems based on Bette's relations just for the basic understanding. Taking my this very famous book in Tomato. Let's see what do we have in store here for us for my students to solve. Hmm. The questions. Yeah, we got one question. Good one. Easy one. Manipulative. Question. What is it given? I'm given one equation x square plus x plus 1 equals 0, whose roots are alpha and beta. Find an equation whose roots are 1 by alpha and 1 by beta. Okay. Easy one. Just use the concept which I made you understand in Vieta's relations for quadratic equations. How? My x square plus x plus 1 equals 0. My alpha plus beta is, as I said, minus b by a. So in this question, my a is 1, b is 1, c is 1. This is a monic quadratic polynomial. Alpha plus beta is basically your minus b by a. So minus 1 by 1, that gives me minus 1. And my alpha beta is 1 by 1, that is 1. I have got these two values. I need to find an equation whose roots are 1 by alpha and 1 by beta. So what have I taught you before? That is, if my alpha and beta or any type, any form of or any processment of alpha and beta is given, how do I need to form my roots? Like this. Here alpha and beta are the roots, but I am given my 1 by alpha and 1 by beta has to be the roots. So here what I have to do in place of alpha plus beta, I will be replacing it with 1 by alpha and 1 by beta. So therefore equation with 1 by alpha comma 1 by beta as roots is basically x square minus 1 by alpha plus 1 by beta of x plus 1 by alpha into 1 by beta equals 0. That's the equation. So I will simplify them and use the information of alpha beta which I find out. So x square minus 1 by alpha plus 1 by beta is basically your alpha beta, and in numerator comes alpha plus beta by alpha beta of x plus 1 by alpha beta equals 0. So in my equation I am already learned that my value of alpha plus beta is minus 1, alpha beta is 1. So minus 1 by 1, that is your minus of minus 1 of x plus 1 by 1 equals 0. So x square plus x plus 1 equals 0. So this is my equation with roots as 1 by alpha and 1 by beta. Similarly, this book has different 10 to 12 questions of based on this Vieta's relations. I will be uploading 3 to 4 in the description box today on a worksheet, which I all expect you to do just as I had uploaded in the previous video too. And I will also be sharing my blogging site and my personal contact details again just for your betterment. And do follow me on my Instagram page, on my LinkedIn, on my GitHub profile too. I am also available 24 into 7 at my WhatsApp number, which is your 9434529524. That is 9434529524 for free guidance and preparation help. So that's it for today, guys. My second video on polynomials and my 8th video in total. I hope you liked the way I taught. Any problems, do comment or tell me personally. I am always open to suggestions and betterments. That's all for today, guys. Do like, share and subscribe the channel and share the videos to your friends who and your juniors, and if parents are seeing this, also to their children who want to have a career in mathematics. So that's all for today. Do like, share and subscribe. Goodbye, guys. See you tomorrow.